Hello everyone. So in this part 2 video, we'll be looking at how we can take select statements and incorporate them into server endpoints. So I'm recording this with the assumption that you're nice and refreshed on both the basics of select and also writing RESTful endpoints in Express. So if you need to, you can rewatch either of those videos below. I'm going to link them in the description. But here, we're going to see how we can re-implement a few reusable patterns that work really well for RESTful endpoint designs. We'll take a look at how we can use parameterized queries to safely implement filtering using user-supplied values with SQL. And then we'll also take a look at what this all looks like put together in an example RESTful app written with Express. So let us go ahead and begin. In this version of our app, I am going to be a little bit space concise. I'm going to import everything all in the same file. For you, I would still recommend breaking this up, creating one file that sets up your database connection and using that database object elsewhere. Having one file that sets up your Express app and then creating your routers elsewhere, sort of the way we've been doing. But in the interest of having it all here, I'm going to show you just how little space we need to set up a app. So I'm going to start once again by making my database connection. I'm going to continue using the same database from last time. This politician database that I have right on my local computer in database demo. And once again, I need to connect once I have that pool. So set that all up. And now I also need to do the setup for my Express app. So this was setting up my database. For Express, I need an app object, and I'm going to need a router object. Like I said, you should do this separate, but we can create it, use it right here. And at the end, app listen on port, let's say 9999 this time. Once it's ready, let us know that the server has started. Great. With all of that out of the way, I've got the basic shell of an Express app here. For our endpoints, each one of these is still going to be a verb called on our router. So maybe when someone visits politician, I want to handle that by calling out to my database. So we've got our database connection here. All I need to do in this request is first figure out, well, what is the query that is represented by requesting this endpoint, which for us is really simple. It's going to be a select from the table that matches the name of our resource. That if your data model is truly unified and you've got similar entities at the endpoint level and at the database level, often you're just selecting everything from one place to the other. In a real production app, it's likely you'll have a couple extra layers here that maybe the format of things in the database differs from the format of things in endpoints. But generally, you're going to be retrieving data with your database object, creating whatever your objects look like in your logical data model here, and then sending those back. So for us, in this very simple pared down example, I can just send this thing back right away. If I actualize this query, send it over our connection, get back a result, which because we have to await this result, I actually have to make this handler async. Then all I need to do is get those results and send back result rows. The rows are what has our actual data. So when someone gets from politician, I select from the politician table, query my database, and then return the results. And that's the most basic, most simplified pattern of writing a GET for a RESTful API that uses a database. If I want to actually test this, I need to first make sure Bun has installed PG and Express. And once I've got both of those, I can run my app.js. It tells me the server is started, which means I should be able to cut over to my rested API tester, visit localhost 9999/politician, and when I make a GET against it, I get back all of the data from my database as JSON objects over here. Each one has all of the columns from the database represented as attributes on these JSON objects in an array, because rows is an entire array. So you can already see that this makes our server-side code pretty simple. All we have to do is figure out, how do we map whatever request the user has to whatever SQL allows us to fetch out those columns and send them back. It makes gets mostly SQL statements. So this is a basic endpoint. Let's try one that's a little bit trickier now. So the other template that we saw for our RESTful APIs was something that looked more like politician and then a wildcard for a primary key, essentially. We had called it some unique identifier, but now that we have our database, it's likely whatever we're putting here is going to be that unique column we can use to fetch out our elements from our entity table. So for us, our politicians are uniquely identified by whatever bio guide they have. I can fetch that bio guide out from the request. Remember, with rec.params.bioguide, this says, look in the query string for a wildcard with that name. So this will give us whatever is put after the slash. Now, if I want to construct my query, all I need to do is say, well, I don't want to give back every politician. I only want to give back ones where this is the bio guide. If you remember from our discussion of select, that is just adding a where clause. I say select everything from politician, but now just where the bio guide equals, and then whatever they put in that requested politician. Once again, I'm going to fire off this request. And now I expect there are two possibilities here. Either I get back a politician and there is a row in my response, or someone gave me a bio guide that doesn't exist. And the request, the SQL statement doesn't fail. It's still going to run. It's just going to return me 0 rows. So if I want to keep using good status codes that communicate to my user what's going on, I can do that by looking at the result row count and seeing, well, how many rows did you get back? If you got back more than 0, you should have only gotten back 1. So I can send that first row, whatever is in that first row, should be the result that you were looking for. Otherwise, if there wasn't anything there, then I can set the status to 404 and send some helpful error message to my user. No politician with that bio guide, sad face. Here you can see once again, even when we have attributes, things that we need to filter on, all we have to do is figure out, how do we map that to some SQL statement most likely by using some form of where clause. So if I want to go and test this, I can run my app again with those changes saved, pop back over to my rested client, and now get still works exactly the same on politician. And if I want to grab, let's say, Maria Cantwell here, if I do politician slash C00127, when I call this endpoint, I just get back the details about that one person. And if I try to put in someone that doesn't exist, W123456, when I run it, it gives me a 404 saying, sorry, there is no one with that bio guide. So this works. Like I said, probably if we were making a real app, there would be a couple extra layers here. We would have real objects and real classes. So we have our database calling, writing the query, and then loading that into some object so that we have methods and then sending it here. But there is one pretty significant weakness with the way that we've written this right now. There's a serious security vulnerability. And that is, we have made a cardinal sin of SQL, which is the user provided us some information, and I concatenated that in a string onto a query. This is bad because I don't have a guarantee that my user is well behaved. If they wanted to, they could put something in here that looks like SQL. Not always, but depending on how you're taking in your parameter, it might be the case that request politician ends up being something like comma and then, or apostrophe, semicolon, drop table, politician, semicolon, and then add another select so that it continues. If I concatenate this in and then just run it here in query, it's going to drop my table. It's going to go and finish this previous statement, run this statement, and run both of them back to back. And not every example of a query can do every type of injection like that, but a best practice, if you are getting something from a user, is rather than using that directly, you can put a parameter in your statement. And the way that you do a parameter is when you write your SQL, instead of concatenating, put a $sign and then a number. In SQL, we start at 1, but if you needed multiple of these, you would do and second column equals $2, and then 3 and 4 and so on. And then to actually supply the value, when we call our query with express, we put a comma and then an array that has all of our parameters in it. So for us, if we only have one parameter here, which is the bio guide, so it's this $1, then we fill in the variable with the bio guide in an array right after our query here. And as an added benefit, this just got cleaner and easier to read. Now there isn't all of those pluses and quotation marks that aren't part of my SQL. I've got one single query here that the database can even cache and optimize. It can say, well, you're going to do this request 100,000 times and just substitute that out. The database can figure out how to efficiently handle your request now that it's parameterized. And more importantly, users can't sneak any SQL into here. This parameterized request won't allow SQL syntax. It's stuck in a string forever. It knows that this is a value, not an entire SQL statement. So now that we've made this change, let's go and run our app one more time, test that it still works, and we can see if the politician doesn't exist, it still fails. If we pick one who does exist, we still get back our result. Parameterized queries are an important step in making sure that your endpoints don't expose vulnerabilities. You always want to be careful if you're moving from one layer to the next that the information you're sending is what that next layer expects and that you are sanitizing anything that is coming from a user. Now that we've done this, we can apply some of these lessons that we've learned in this endpoint back to our original politician. So you might remember in our previous video working with RESTful endpoints, it was common for us to allow people to perform filtering on this entire collection. We had said, well, you can hit localhost/politician and then put query string parameters by putting a question mark and saying maybe something like first name equals Sherrod. If I want to allow this in my endpoint here, I need to figure out some way that I can build this query. And this is definitely going to be the most complex query that we've written so far, because I don't know what parameters will or will not be applied. So there are a couple different ways I could do this. No matter what, whatever strategy I'm going with, somewhere in the beginning, I need to supply the list of what people can even put. So I'm going to make this collection of search params here. Say there's a first name, a last name, party, and member of will be the 4 things that I allow people to filter on. And to make life easy for myself for this example, I'm even making them the same as my column names, which are the same as my attribute names. If they're all different, you're going to need to do some translation from step to step. But the way I'm going to do this is each one of these is another where clause that we can add onto this query that we're building. So if I have some group of clauses, which are all of the things that people have built together, ultimately what this is going to be is my query will be what it was before plus where plus all of these potential clauses of things that they could have searched joined with and. So now all I need to do is figure out, okay, how do I fill in each of these potential clauses? So for each possible thing that the user could have put, each param of those search params that they could be searching on, I'm going to create a clause that represents that. Let that clause be, I need a $sign with a number, so some number, but it's going to change each time. That number equals that param. So like if they're searching for first name has to equal $1. If they're searching for last name has to equal $2. Party equals $3. That means probably I'm going to need some kind of counter. So we'll say there's a param count, starts at 0, goes up by 1 every time we run this loop. So now I've got a wild card will be that percent and that param count. That solves this problem. So it's now our clause. I'm going to use a fancy string with the backticks in JavaScript because that'll let us put the wildcard right in there. Either the wildcard equals whatever the param is, first name, last name, whatever, or there's another possibility. Or that wildcard, that %1, is null. It equals null. Either one of those is a way that we want to give this result back. If someone is searching on first name, then their first name has to equal whatever they put in our %1. If they didn't put first name, then my request still is going to have a %1 because otherwise I can't keep track of what's what, but nothing is going to be filled in there. So it's going to be null. If either one of those is true, then I want to return this result. So I'm going to put that in parentheses and say, well, this clause gets pushed onto my clauses. Now, I also need to record, well, whatever is in the request parameters, that's going to be a query string variable. So I'm going to make a parallel array here and say, well, on my query string variables, let's push this request query parameter. So request.query.firstName will get me the first name. Request.query.lastName get me the last name. Or if there was nothing in there, put null in our query. So this is a dense little snippet, a dense little loop. All this is doing is saying, go parameter by parameter and construct a thing that's either looking for a match or is looking for something the user didn't put at all. Collect all of these different snippets of Boolean logic and then join them together in a where clause. So what this is going to look like in the end is something like select star from politician where $1 equals first name or $1 is null. And $2 equals last name or $2 is null. And $3 is party or $3 is null. And the reason we're constructing our query this way is so that whether or not someone put any particular attribute, we're either going to filter on that attribute or not care that it's not there. And we're testing each one of these conditions. This strategy is a little bit cheeky and it only works because these names match our attribute names, which won't always be true in real production apps. But you can add a couple extra layers, a couple extra dictionaries that map one name to the other and still make this general strategy work. Once we've got our query here, we're going to supply the query with the query string variables that we also built up alongside our clauses. And now, if we restart our server after saving those changes, when I pop over, if we run politician by itself, we still get back all of the results. But now I can put my question mark and say, oh, well, I only want just the Democrats. Only show me the Democrats from the list. And you can see now every single result has party set to D and it's filtered out all of the rest. I could say, get me only the results where first name equals Amy. And when I run this, I only get the results where the first name is Amy, which apparently is only a single one of them. I could say, well, get me the results where someone is a member of the Senate and their first name is Mike, and I'll get back just the senators whose name is Mike. We now have the ability to do all of the filtering for our endpoints, and in our code, the entire query, that entire request logic is just built up in our SQL statement here. This general pattern will work for pretty much any RESTful endpoint you can think of. It doesn't matter what this resource is, what these particular columns are, as long as you can find a way to express the thing your user is looking for in a SQL query, you can write all of that logic in the query itself. So this is not the only approach for doing SQL gets. We have a video coming up where we will explore how we could use an ORM to also do this. But this is a nice, simple, elegant approach for writing RESTful APIs backed by a database. We've seen simple requests where we're just selecting an entire table. We've seen requests where we filter on a single attribute and check the response to see what status code we should return. We've even seen how you can make filtering with query string parameters to fetch data based on the conditions that the user cares about. From here, we're going to be talking about how we can also incorporate other actions, things like posts and puts. So I look forward to that, and I will catch you all in the next one.